Hi, welcome to IoT Lab experiment number 7, and today we are going to perform traffic lights using Raspberry Pi 4. For this experiment, we will be creating and simulating 4 different programs. For the first 2 programs, we will be using the circuit GPIO2 for LED red, GPIO3 for LED orange or amber, and GPIO4 for LED green. The GPIO2, 3, 4 are connected to the anodes of the LED, and the cathodes of the LED are connected to a resistor and is connected to the ground. This black wire is connected to the ground pin of the RPi4. For the first program, this will be our code wherein we import traffic lights from GPIO0 and we import sleep from time. And our assigned GPIOs 2, 3, and 4 is assigned to lights, wherein this will be our while loop for the traffic light sequence. And when we simulate this program, the green LED will initially turn on. And after 10 seconds, the green LED turns off and the amber LED turns on. After 1 second, amber LED turns off and the red LED turns on for 10 seconds. And after that, the amber LED turns on also. And after 1 second, the amber and red LED turns off and the green LED turns on. Since this is inside the while loop, this will loop endlessly. Now let's test the first program. First, the green light is on for 10 seconds. And after 10 seconds, the amber light should turn on. There. For 1 second, then red for 10 seconds. 3, 4, 5, 6, 7, 8, 9, 10. Then amber. Then green. 1, 7, 8, 9, 10. Okay, amber. Then red. Now for the second program, we import traffic lights from GPIO0, we import sleep from time, and we also import pause from signal. Now we assign the GPIO2, 3, and 4 to traffic lights, the same as program number 1. Then we define traffic light underscore sequence, which consists of a while loop wherein we use yield, and these 3 values corresponds to the GPIO2, 3, and 4. So these are the values. So first value. So for the first yield, GPIO2 has a value of 0, GPIO3 has a value of 0, and GPIO4 has a value of 1, which turns the green LED on. Then after 10 seconds, the green LED turns off with the value of 0, and the amber LED turns on with the value of 1. Also, the red LED is turned off. Then after 1 second, the red LED turns on with the value of 1, and amber and green LED turns off with the value of 0. And after 10 seconds, red LED and amber LED turns on with the value of 1, and the green LED remains off with the value of 0. And after 1 second, the code loops back to the first condition. Then light the source equals traffic light sequence, then pause. Now let's test the second program where we import pause. Then, see, red, 1, 5, 6, 7, 8, 9, 10, amber, okay, turn on, then green, 5, 6, 7, 8, 9, 10, amber, then red, for 10 seconds again. We can observe that this code and the previous code resulted to the same execution of the light traffic system. For the two-way traffic system, the first 3 represents the first traffic system, and the second 3 represents the second traffic system. So for the first traffic system, we assign GPIO2 for red LED, GPIO3 for amber LED, and GPIO4 for green LED. For the second traffic system, we assign GPIO17 for the red LED, GPIO27 for the amber LED, and GPIO22 for the green LED of the second traffic system. All the GPIOs coming from the RPi4 are connected to the anode of the LEDs, and the cathodes of the LEDs are connected to a resistor, and the other end of the resistor is connected to the ground, wherein this black wire is connected to the ground pin of the RPi4. Now let's create the code. For the two-way traffic system, I use a different code method wherein we import RPi.GPIO as GPIO, and we import sleep from time. Then with GPIO set mode, GPIO.BCM, so we can set GPIO numbering, then GPIO.set warning false. Then for the first traffic system, GPIO2 for red LED 1, GPIO3 for amber LED 1, GPIO4 for green LED 1. For the second traffic system, we assign GPIO17 for red LED 2, GPIO27 for amber LED 2, and GPIO22 for green LED 2. Then we use a while loop for the traffic sequence. For the first condition, when the green LED of the first traffic system is on, the red LED of the second traffic system is on. Also, the red LED of the first traffic system is off, and the green LED of the second traffic system is off. And after 10 seconds, the green LED of the first traffic system turns off, and the red LED of the second traffic system is also off. Then, both amber LEDs of the first and second traffic system will be on. Then, after 1 second, both amber LEDs of the second and first traffic system will be off. After that, the red LED of the first traffic system will be on, and the green LED of the second traffic system will be on for 10 seconds. Then the cycle repeats and repeats again. Then finally, this block will run no matter how the try block exits. Then GPIO cleanup. Now let's test and run the circuit. Now let's test the two-way traffic system. Here's the first traffic system and this is the second traffic system. I will run again the Python code. There. First traffic system is green light, then second traffic system is red light, then amber for 1 second, then red for first traffic, then green for second traffic. For the one-way traffic system with pedestrian button control, this will be our circuit, wherein we assign GPIO17 for the red LED, GPIO27 for the amber LED, and GPIO22 for the green LED, wherein the GPIOs are connected to the anode of the LED, and the cathodes of the LED are connected to the resistor, wherein the other end of the resistor is connected to the ground, and this black wire is connected to the ground of the RPi4. For the push button control, this pin is also connected to the ground, and the other pin is connected to GPIO2. For the fourth program, this will be the code for the one-way traffic system with pedestrian button control. So we import traffic lights button from GPIO0, we import sleep from time. For the lights equals traffic lights, we assign GPIO17 for red LED, GPIO27 for amber LED, and GPIO22 for green LED. Then for the push button, we assign GPIO2. Then when we simulate the circuit, the green LED is initially turned on. Then inside the while loop, the button will wait to be pressed. Then when the button is pressed, the program will execute the following traffic light sequence. Assuming we want to cross a fast highway, and there is a pedestrian button control, so when we press the button, the green light will blink 2 times as a set warning for the motorist to slow down. Then after the 2 blinks, the green LED turns off and the amber LED turns on for 1 second. And after 1 second, the amber LED turns off and the red LED or red light turns on for 10 seconds. After 10 seconds, the red LED turns off and the amber LED turns on for 1 second. And after that, amber LED turns off and the green LED turns on. Then after that, the code goes back to the first condition, wherein the button will be waiting to be pressed to execute again this following code. Now let's test the circuit. Assuming that we want to cross a fast highway, we just need to press the pedestrian button control. Then the green light will blink as a warning to the motorist to stop. Then red line will turn on for 10 seconds. There, let's press again. Green light will blink. So warning for the motorist to slow down. Then yellow, then red for 10 seconds. 3, 4, 5, 6, 7, 8, 9, 10. Yellow, then green. There.